All right, that was the percentage yield question I left you with. So let's start with the beginning of the question. Ample amount of aluminum reacts with 100 decimeter cube of oxygen to produce Al2O3. Now the percentage yield of Al2O3 was 92.6%. We need to calculate the amount of Al2O3 actually produced. The question is already given, and luckily it's already balanced. We have the steps that you need to go with. So the first step really is moles of oxygen reacted, and this is a formula step. So solving this step over here, moles, as per our formula, is equal to volume over molar volume. Now, how do I know that I need to use this formula? So, okay, this is oxygen, and the information gives you the unit decimeter cube. As soon as you look at it, you would know that the formula you need to use is volume over molar volume, right? So that is 100 volume. The value for molar volume is always 24. It never changes. So if you remember that by heart, it shouldn't be a problem. And this is 4.166 or 4.16 decimeter cube. You can stick to three significant figures. You can go as high as to four significant figures. It's entirely up to you. So let's stick to just three significant figures, 4.16. Make sense?
Yes, sir.
Good. Moving on to part two, moles of aluminum oxide produced, and this is a ratio step. Since we need to ratio of oxygen, so we are going to be using this. So in order to solve this part, O2 that we have the information about, Al2O3 as the steps demands, and we need to calculate this one. From the balanced chemical equation, O2 is 3. So I'm going to write it as 3 ratio. Al2O2 is 2. So I'm going to write it as 2. But my question says it is not exactly 3, it's 4.16. So I'm going to write it over here, 4.16. And this is the one I need to find. So let's put the division symbols. Let's rearrange them. X would be equal to 2 multiplied by 4.16 and divided by 3. That's how it's going to be.
Sir, I'm kind of confused, sir. In the first part, how did we get 24 with the molar volume?
The value for molar volume for all the gases on the planet is 24 at room temperature and pressure. So you need to remember this value. It's pretty easy. The value for molar volume for any gas on this planet is 24. So whether it's oxygen, whether it's nitrogen, whether it's any other gas of the planet, this is the same value that you need to take. This is quoted in the book, and you need to remember it by heart.
All right.
Okay? Molar
Okay.
volume means the volume for any gas at room temperature and pressure, and really any gas on the planet, be it oxygen, nitrogen, chlorine, or fluorine, or nitrogen oxide, carbon monoxide, name any gas, it would have the same volume at room temperature and pressure, and that is 24 decimeter cube. 1 mole of that gas would always cover the same space, the same volume. So we remember this value by heart. Okay.
All right, sir.
So coming back to this part, if you have the calculator in front of you, you're going to help me with the calculation. So multiply 2 by 4.16, divide all of it by 3, and let me know what the answer is.
Sir, the answer is 2.773.
So I'm going to stick with three significant figures to 2.77 decimeter, sorry, not decimeter cube, my bad. The previous one was also not decimeter cube. I put the wrong units over there, as well as over here. This one's mole, and really this one is also mole. So 2.77 mole. And I'm going to put the same value over here, 2.77. That's my answer. So the mass of Al2O3 produced in grams. That's my third step, and I'm going to do it over here. And again, the formula says mass is equal to moles into MR. Now, I need to calculate MR separately. So the MR for Al2O3, since Al is 27, so 27 multiplied by 2 as per the periodic table. And oxygen in the periodic table is 16, so 16 multiplied by 3, this becomes 54, this becomes 48. The answer really is 102. Okay, I hope I'm correct. Do correct me if I'm wrong. Since I don't have the calculator, I'm doing it mentally, so I may be wrong at a point. Let me know where I am, if I am.
Okay.
Okay, so this is what we do need to do next. 102 is multiplied by 2.77 mole, which was the answer to previous part of the question. What's the answer to this one?
Answer, it's 282.54.
283.5. Let's stick to just one.
282, sir. 282.
282.5, right?
Yes, sir.
I'm gonna erase it all, and 282.5. Okay, that's the theoretical value. That's the predicted yield. This is py, right? So I'm going to put the values over here. The percentage yield is quoted in the question, 92.61. So I'm going to put 92.61 over here. And the predicted yield, as my answers say, is 282.5. And I need to divide this whole thing by 100. So my actual yield is going to be $250 something, 256 or 258 probably. What is this? Actually, it might cross 260. So the answer is so it's 92.61 multiplied by 282.5, and then we divide the whole thing by 100. The answer comes out to be, I was right in my latter anticipation, it is 261.62. What am I doing? Let me write that correctly. So 261.62 grams. Okay. That is what has been actually produced out of this whole question. And that's the answer to the question. Okay. So if you feel any confusion from it, do let me know.
Sir, I'm clear right now. Yeah, it's clear.
That'd be great. But I still think we need to do a couple of questions more for the percentage yield so that the concepts for percentage yield become better to you, right?
Yes, sir.
The more you're going to practice, the more confident you're going to feel about it. So yeah, I'm gonna save it like this, and I'm gonna pause sharing for a while, just a minute. And let me go with, all right, continuing with our next question. Question number 3 this time. Let me think of an equation. Okay. Yeah, this is going to be a great one. Calcium carbonate, CaCO3, reacted with ample amount, ample means excess, ample amount of, which acid should we go with? H3PO4, phosphoric acid, to form A3PO4 twice. And this is also going to form, apart from Ca3PO4, CO2 and H2O. As CaCO3 plus H3PO4, giving us Ca3PO4 twice plus CO2 plus H2O. Yeah, I think it's a balanced equation now. So to calculate percentage yield of CO2 produced. Okay. So the parts to the question are: 1, moles of CaCO3 used. That would be in mole. Part 2 would be moles of CO2 or carbon dioxide produced. And that would again be in mole. Lastly, to think about the predicted yield, volume of CO2 produced. Now, when I really write the words as volume or mass or moles, this really gives you the idea to use which formula. Okay. So let me tell you again, this is a formula step. This is a ratio step. And again, this is a formula step. To be honest, this also gives you the predicted yield. So it's PY. And lastly, our part 4 is percentage yield, which is going to be AY over PY into 100. That's how it would go. We already have the actual yield as a part of the question, which is 1 decimeter cube of carbon dioxide. Okay, so go ahead, take a try on this one. Wherever think you get confused, let me know. I'm here and I will help you with it. Since we're at it, and I'm going to help you even with the formulae, so it's easier for you to perform your steps. This one is going to be moles is equal to mass over mr. Now you can separately calculate the mr, and let me tell you that mr of CaCO3 is 100, and that of CO2 is 44. So it's easier for you to directly just jump into the question. Since you are going to have MR, it would be easier for you. Okay, so this really is going to be CaCO3 ratio CO2. Okay, and this one is going to be then volume is equal to moles into molar volume. Okay, now you have the formulae or the steps to all of these 3 parts. This should now be easy. Keep doing the steps, and wherever you get stuck or wherever you're unsure about whether your answer is correct or not, let me know your answers. We'll calculate it together so that it's easier for you to get your answers right. Okay. Second, in order to clear out the confusion, remember ratio has 2 steps. In the first step, you quote the numbers from the balanced chemical equation under the chemicals as given. So for CaCO3 over here, as you can see, okay, that CaCO3 is ready. Just a second. Just a minute. Okay. So as CaCO3 is 3 over here, so I'm going to write 3 over here. And as CO2 is 3 over here, so I'm going to write 3 over here. Okay. And then use the number for CaCO3, which was given in the previous question. Since it's not 3 moles of calcium carbonate that produces 3 moles of carbon dioxide here, it's actually 0.15 moles. So we need to figure this one out. Now, as I've told you before, that if the numbers up top are same, the x is going to be as the number for the other one. So here, really, x is equal to 0.15. So the answer over here is also 0.15. Okay, so that's how it's going to be. Make
Okay.
sense?
Okay. Yes, sir.
Then you can really get on with the next step. Remember, as I told you before, the value for molar volume is 24 decimeter cube per mole for any gas on the planet. So even if it's CO2, the value of molar volume would stay as 24 decimeter cube per mole. Okay? So these are the key things that we've used in this question. Go ahead, work the last part out, let me know. Oh, third part out, let me know. That's actually the second last part. So you just said 0.545. So if you are actually multiplying 0.15 by 24, and then your answer comes out to be 0.545, then you're correct. Have you done the same thing?
Sir, what I did was I used the formula volume over moles, so I just 24 divided by 44, which gave me 0.545.
No, actually, you were supposed to do it like this. Molar volume is 24, moles are 0.15, so you multiply them as stated in the formula. So try doing this and let me know what the answer comes out to be if you solve this on the calculator.
Sir, what does PY mean? Like there's form and then there's PY.
Py means predicted yield.
Okay.
That's the same value you're going to use in part 4. Okay. I'm going to state it over here so that you don't have a problem understanding it. So this one is actual yield, and this one is predicted yield. I've taken this as AY. I've taken this as PY and then multiplied by 100. So this is what I've done over here. So I've made the formula simple. Instead of every time writing the whole thing, actual yield, I'm representing it with AY and predicting yield by PY. This is for my own ease. You don't exactly need to do that in the exam, but even if you do, that's fine. So what is the answer when you multiply 0.15 by 24?
Sir, it is 3.6.
3.6 decimeter cube. So I'm going to write 3.60 over here, since we need to write 3 significant figures. Okay, so here's the actual yield, 1 decimeter cube. So it's 1 over here, and it's 3.6, which is my predicted yield, and multiplied by 100. So the percentage yield comes out to be
27.77 77 or 27.7.
I don't get it. 7.7?
27.7.
How come there are 2 points? Are you saying something different? I don't get it.
Sir, the answer is 27.7.
Oh, 27.7. My bad. Sorry, I don't get it the first time. 27.7%. I thought you were saying 0.7, and I was confused. Why are you including 2 points and not one? Okay, 27.7%. There you go. And I guess that's the correct answer to it. Seems right. Now let me know. Do you
Yeah, it's clear. I
better?
could do another question. Yes, sir. I could do another question.
Good, good. So let's move to another question then. I'm gonna use a similar question to the previous one. So question number 4. Lithium reacts with excess of H2SO4 to form Li2SO4 as all right. So lithium alloy reacts with excess of H2SO4 to form lithium sulfate Li2SO4 as given in the equation, in which 2 moles of lithium reacts with 1 mole of sulfuric acid to form 1 mole of lithium sulfate and 1 mole of hydrogen. The equation is already balanced. So if 1 gram of lithium only produces 100 cubic centimeter of hydrogen, calculate percentage yield of hydrogen. Now this time I am going to leave you with the steps, but this time I won't mention formula ratio step because it's pretty much the same thing. Also, I'm not going to help you with PYs and AYs because that's also something that you already understand from the question, okay? So let's just try to go with the steps that Cambridge gives you and nothing extra on top of it. So moles of Li reacted, number 2, moles of H2 produced hydrogen gas, and number 3, it's just like the previous question, it shouldn't be a problem, right? So
Yes, sir.
volume of H2 produced. So you have all the formulae already there with you. Decimeter cube. This time there is a trick in the question. I've given the volume in centimeter cube and you'll get the answer in decimeter cube. So you will need to convert the centimeter cube into decimeter cube in step 4, not in any of the previous steps, but in step 4, all right? So percentage yield is equal to AY over PY into 100. AY is this 100 cubic centimeter, convert it into decimeter cube, then use it over here. PY is going to be the answer to step 3. You know what to do with the rest.
Sir, it's step 3, so we just have to find the answer in decimeter cube, not in the predict yield
This is the
type
predicted
of
yield.
formula. Okay.
The answer to step 3 in decimeter cube is itself the predicted yield, because you're theoretically calculating the answer to hydrogen. That's not what actually was produced. What actually was produced is written in the question was only 100 cubic centimeter, which you're going to convert in decimeter cube before you use it in step 4.
All right. Okay, sir.
Okay, so MR slash AR, whatever that is, right? So for lithium, that is 7, and for H2, that is 2. So in this question, you need to deal with very simple numbers. Yeah. So this would be really easy. So you can do the whole thing really quickly. But again, I am going to just wait for you, and you are going to coordinate with me step by step. Don't try to solve the whole question. After every step, let me know what you have done. Okay? I'm going to wait. You're saying the first answer is 0.142 because I hope you have done it in this way. Moles is equal to mass over molar mass, which you took as 1 over 7, and the answer came out to be 0.142 moles. Is that right?
Yes, sir.
Great. So moving on to part 2. Great. Which means you did it correctly. It's like this. And then you assumed it to be x. Later on, you solved x as 0.142 divided by 2, and your answer came out to be 0.071, right?
Yes, sir.
Great. I'm going to just keep 3 significant figures for this answer, and I'm going to ignore the rest, okay, as per the rules of Cambridge. So let's move on to third step. Perfect. I guess if you have the right answers, so you must have applied the right formula. So you must have multiplied by moles with the molar volume, which means 0.071 multiplied by 24. So I'm not entirely sure, but I guess the answer is pretty close, right? And this was your answer, which you just told me, 1.704.
Yes, sir.
Okay, great. This is the answer to decimeter cube. Now, either you convert this decimeter cube into centimeter cube for this formula, or you convert the centimeter cube into decimeter cube for this formula. It's entirely up to you. But remember, in yield, both the units for AY and PY are supposed to be the same. So it's entirely up to you which one do you convert. Remember, 1 decimeter cube is equal to 1,000 centimeter cubes. Okay. So if you convert centimeter into decimeter cube, you're going to divide by 1,000. If you convert decimeter cube into centimeter cube, you're going to multiply by 1,000. It's up to you which one you pick.
So, sir, it isn't really required in the question that I have to
But
change it.
whichever one you want. You can either put both of them in centimeter cube, or you can put both of them in decimeter cube. Both way, your answer is going to be right. So it's really the choice of the student what he picks to do.
Okay, sir.
So what would you like to do? Are you going to take it in cubic centimeter or decimeter cube?
Sir, decimeter cube.
Okay, then convert this 100 into decimeter cube by dividing it by 1,000. So if you divide this one by 1,000, you'll get your answer in decimeter cube, which is
0.1
0.1.
decimeter cube.
Great, 0.1 decimeter cube. So I'm going to use this 0.1 over here. And since you might already be doing the same, so there you go. And that's your last step. Remember, this time you're going to come up with three significant figures, but since this is the final answer, you're going to round off your value to three significant figures. So basically, just don't take the first three significant figures, round off the fourth or the fifth digit in order to get your value. So your value might change by a digit or two. By a digit, of course, not two, of course.
Sure. So the answer would be 5.868, or just 5.86.
No, rounding off means that so it's 5.868. Now, if I round it off, I'm going to increase it to 5.87. So really, it would be actually 5.87 to be the correct answer. So
Like you said, it's necessary that
5.87%.
we have to round off, right? Yeah.
But you only do it with the final answer, none of the previous step. It has to be the last step that is rounded off to three significant figures.
All right. Okay.
So there you go. You've done it all by yourself and you have done it correctly. That means you must be confident about it too.
Yes, sir.
Good, good.
So, if you could send some practice questions, you know, just to really solidify it, you know.
Sure, sure. What I'm going to do is that I'm going to pick a few past paper questions and I'm going to send you those. That would be better if you solve past paper
Right.
questions to it. Yeah,
Sure. Sure.
great. All right. So